Hello students, in this video we are discussing Cbse class 9 science NCERT textbook chapter 8 motion, and we are discussing the fifth part of this series. Okay, we have already discussed this lesson in 4 parts. We have discussed few topics, and today we are going to discuss the fifth part of the video. Now we are going to learn about the next concept called acceleration. So previously we've discussed about the concepts speed, average speed, velocity, average velocity, uniform and non-uniform motion. Before that we learned about distance, displacement, scalar quantity and vector quantity. Okay, now we are going to get into the next level, that is going to be the acceleration. So where do you use the word accelerate? Accelerate is a common word which you have already come across. Okay, accelerate means you generally use this word accelerate when you try to go faster. Okay, so when you're going to travel fast, you say that you accelerate. You go at a faster speed. That is your acceleration, which we all know. Okay. This acceleration here in physics we are naming it as rate of change of velocity. Before we get into the actual concept of acceleration, we are going to try to understand the meaning of the word rate. Okay, in physics the word rate is better understood as a rate of change. Rate means what? We generally use the word rate to say at what pace. At what pace? Pace in the sense at what speed at in a given time, how much we are able to do or something like that. Okay, so this refers to how much one quantity changes when another quantity changes, and it is from this we are able to say that we are going to compare something, so it is a ratio. And generally in physics, wherever we talk about the word rate, the quantity of comparison is going to be nothing but time. Okay, it is going to be nothing but your time. Now we'll get into the actual concept. So acceleration is the rate of change of velocity. So again the same thing I've given here. Acceleration is nothing but the rate of change of velocity. Why velocity? Because we use the word accelerate when we are going to increase the speed or decrease the speed. So when we are going to change the speed, then automatically we say that there comes the concept of velocity. So when will velocity change? Velocity will change when there is a change in the magnitude of the speed or the direction or both. When this velocity is itself going to change, then we talk about acceleration. So acceleration is what? Rate of change of velocity. So wherever you have the word rate, you can see that you will be writing the time taken in the denominator. So acceleration is what? Rate of change of velocity. So change of velocity will go to the numerator, and the time taken will go to the denominator. So the SI unit of acceleration is meter per second square. Why meter per second square? We just do it now. Okay, so we have change in velocity. So change in velocity, the unit is going to be, if I'm going to have the velocity to be, generally we take the final velocity to be v and the initial velocity to be u. So change in velocity we can mention it as v minus u. I'm going to take u to be 2 meter per second and v to be 5 meter per second and the time taken to be 1 second. So how will I write now the change in velocity? How will I do? It will be what? 5 meter per second minus 2 meter per second divided by 1 second. So in that case 5 minus 2 will be what? 3 meter per second divided by 1 second. So what do we have here? 3 by 1 is going to be 3, and see, I already have meter by second by second. So I am going to have meter per second by second, which you can write it as meter by s into s, or you can write it as meter per second square. Okay, so the unit of acceleration is meter per second square, and that is what is given here. And acceleration is a vector quantity, so obviously the value can be either positive or negative or 0. So this is all about your acceleration. So you can see this picture. Notice it carefully. First, the acceleration is 1 meter per second square. So 1 meter per second is the velocity. See, acceleration is remaining the same, but velocity keeps on changing. That means for every 1 second, acceleration is the velocity is going to increase again. Okay, first it was at 0 because it was at rest. After that, there was uniform acceleration. So you could see that it slowly started picking up the speed. You can see the speed is increasing. You can see the speed to be increasing slowly. So that is what we can say here. And then it hit that object and it came to a stop. See the velocity and acceleration. Look at this picture carefully along with the values, then you will be able to understand. It is slowly increasing and then it is going to come to a stop because it is going to hit some object here, okay, or it is going to apply some brakes. Again, we'll just do a final conclusion. Acceleration is nothing but the change of velocity, that is rate of change of velocity. So it is nothing but change of velocity divided by time. So what is acceleration? Measure of a change in velocity of an object per unit time. Now, as we learnt about average velocity, when we learnt about uniform and non-uniform motion. So hereafter we will be learning about uniform and non-uniform motion almost in many cases. So we are going to learn about uniform and non-uniform motion for acceleration also. So if it is going to be uniform motion, what will happen? The final velocity and the initial velocity will be 0, isn't it? The final velocity, I told you, right, rate of change of velocity. So if it is uniform motion, u is going to be v equal to v. Upper change in velocity will be what? That is going to be 0. Change in velocity is going to be 0. So 0 by t will be what? 0. So my acceleration will be 0. That is what we are going to see here. Look at these points here. The change of velocity for an object in uniform motion is 0 as the velocity remains constant at any given time interval. So at any time interval if you take, you can say that it is going to be 0 because the acceleration and finally the acceleration is 0. But for non-uniform motion, the velocity will keep on changing with respect to time. Okay, the velocity will keep on changing with respect to time. Hence, the change of velocity is not going to be 0 because you will have a value for v minus u. So this acceleration will have a value. Again, the SI unit of acceleration is meter per second square. The SI unit of acceleration is meter per second square. That is not going to change, be it any type of motion. Now that we've learnt about uniform and non-uniform acceleration, we also need to learn about positive and negative acceleration. So what is positive and negative acceleration? We kept on using the word speeding up. We want to increase our speed when we spoke about acceleration. But not only do we increase our speed, but we also decrease our speed. So if we decrease our speed, then we can say that the acceleration is said to be in the negative. Because in the previous sometime before we also learned that acceleration can be positive, negative or 0. Now we have learned that it is going to be 0 for uniform motion. For uniform motion it is going to be 0. So we have positive and negative. So positive when you are going to be speeding up, when you are going to increase the speed. Likewise, when you are going to decrease the speed, it is going to be called as negative acceleration. So that means you have the formula v minus u. So v minus u is what? Final minus initial. So when it is going to be positive acceleration, your v will be greater than u, and for negative acceleration, your v will be less than u. And there are two other words for negative acceleration, that is deceleration or retardation. It is also called deceleration or retardation. So negative acceleration is said to be deceleration or retardation. Now again we'll just do a quick recap for uniform and non-uniform acceleration. When does this happen? Uniform acceleration. If an object is going to travel in a straight line and its velocity changes by an equal amount in equal intervals of time, okay, by an equal amount in equal intervals of time, then the acceleration is said to be uniform. But when it is going to change at a non-uniform rate, then we can say that the object is said to be in non-uniform acceleration. So this is regarding your uniform and non-uniform acceleration and positive and negative acceleration. So in this video, we've learned the entire concept of acceleration in detail. So in the next part of this series, we'll be learning few numericals based on the concepts which I learned from the beginning of the lesson till now. Hope you all have understood what we've discussed today. We'll meet you again in another video, children. Thank you, children.